Okay, I'm back. I had to pause because I had an interruption there, but just go ahead and continue. Our answer for this one then would be x equals, and depending on how many decimal places, we would write out our answer. Many of our problems ask for 10 thousandths, which is 4 decimal places. So if we go out here to the 4th decimal place, that's the 3. But then if we look at the decimal place after it, there's a 9. Well, that means we have to bump the 3 up to 4. So when we write it, we will say that x equals 2.194, and then that 3 turns into a 4. So we're able to give very precise answers this way. Let's look at another example that has a little bit of algebra in it. Okay, second example. This one has a little work to do. So this is where that first step, isolate the exponential, comes in. Right now, there's this 6 over here that's with the exponential, 12 to the power 4x. We've got to get rid of the 6. So think to yourself, is it 6 times this, 6 plus this? What is the operation? Well, if there's nothing written here, it must be times. So we're going to undo that. You guys should be getting good at undoing. We're going to divide by 6, since the opposite of multiply is divide. We do have to do that on both sides of the equal sign. Do not divide this piece. Divide once here and once on this side of the equal. Divide everything over here. Of course, on the left, 6 over 6 makes 1, so now we just have 12 to the power 4x equals whatever we get when we take 128 divided by 6, which is 21.33. 33. All right. Next step, rewrite as a logarithm. So we're going to rewrite this as a log. Log, drop and swap, so drop the 12, log base 12, swap these two, so 21.333 comes over here, and the 4x that was in the exponent goes to the other side. Next step, we still have to solve, well, next step says use the calculator, so let's get this number using our calculator. Alpha window, number 5, log base 12 of 21.3333 gives me this number. I'm going to write that down, 1.231, and if I'm going to drop the 4, that means the 5 stays put. I don't have to round it up because 4 is less than 5. All right, that equals 4x. And finally, I have a fairly simple algebra problem to solve. I just have to get x by itself here. So to do that, 4 times x, the opposite is division. I divide both sides by 4. So this is just a much simpler algebra problem. It just has decimals. I'm going to hit divide by 4 here on my calculator without even taking it out. And I get my answer 0.307. Now if I look here, I'm going to drop this second 8, which means I do have to bump that 8 up to 9. And that equals x. Final answer, so I probably want to circle it to show, hey, all this work got me to there. All right, one final example. This one's a little bit different because it has a different base. So let me slide these up. Again, if you need to pause it because I went too fast, pause it. But last example for these notes. All right, these are different because the base here is the letter E. And we haven't dealt much with the letter E before. E is just a number, actually, kind of like pi. It's one of those special numbers that goes on forever and has a special meaning. It's the limit as 1 over n approaches infinity, but we aren't going to deal with that too much right now. It's basically 2.72 and on and on and on. E does have a key on the calculator just like pi does. I'm going to cover that up for just a second. If you see right here above the divide sign, there's a little e there. You can use that, or if you need e to a power, it's above the ln sign. If you look at the little blue e to the power x there. It's just a number just the same way pi is, though. It's not a variable. So when we go to solve it, we're just going to do log base e. But log base e is a special number or a special logarithm. That's the one that I told you to just type in your calculator the other day as ln. If you forget that, notice that e and ln share the same key. That's because they're inverses or opposites of each other. So when we go to rewrite this, the first thing we got to do is isolate the exponential. Well, this piece right here is the exponential, e to the power 5x minus 6. So what else is on the same side of the equal sign with it? Hopefully you said this minus 4 that's not in the exponent. So we're going to add 4 to both sides. That leaves me on the left with e to the power 5x minus 6. And on the right side, 54. Next step, I'm going to do the drop and swap. Okay, log base e though, which is what we would have to do, is the same as ln. So rather than doing log base e, let's just make a little note of that. Log base e is ln, and I usually write it in cursive because otherwise it looks like 1n. Ln. So we're going to do ln instead of log base e here. We still swap, so we're going to swap these two pieces. So 54 comes over here, and the 5x minus 6 goes over here. Let's slide it up a little. Next thing I'm going to do is use the calculator to get the ln of 54. Remember, ln has its own special key right here. So I'm going to do ln of 54. And I get 3.9889, but that 8 rounds up to 9. So basically 3.989. Bring the rest down. Now I just have a simple algebra problem to solve. Where should I start in getting x by itself? The minus 6 needs to be undone, so I add 6 to both sides. That gives me 9.989 equals 5x. And what's the final step to getting x by itself? Because this is 5 times x, we're going to divide by 5. So I'm going to take 9.989 divided by 5. It's going to come out very close to 2, 1.9978. All right, and that is our answer. So that's the hardest one you'll have to do, is something like this on today's worksheet. Hopefully, if you have any questions, maybe Mr. Radicke can help one person at a time. So don't feel like you can't ask, or potentially Miss Rhodes might be able to help you out. But I hope that if you're not sure, go back and watch an example. Then if you're still stuck, see if you can find some help. Well, as I said, if you're not 100% comfortable with this, we'll go back over it on Monday. Hope to see you then. Bye-bye.